Okay, so hello everyone in a new session with Google Developer Group, our chapter North Lebanon. Today we are having a very special speaker from Google, Mr. Wesley Chan. He's Google Developer Advocate in Google Cloud. Hello, Mr. Wesley, how are you?
Good morning. Can you hear me?
Yes, I am hearing you. In Lebanon, it's evening, so people are attending. Yes, so it's morning for Mr. Wesley, but it's evening for us, so it's no problem. Thanks for the
Okay,
online
I see.
experience.
So
Yes.
I should say Sabah al khair.
Oh, yeah, so, exactly. So I will stop presenting. You can start your share screen and start the session. Thank you.
Great. Let me get everything ready here. Okay. I hope this works. Let's try this one. Shrink it a little bit so everybody can see. Okay, great. All right. Thank you very much for the intro, Abdel. Welcome, everyone. My name is Wesley Chan. I'm a developer advocate at Google. And hold on a second. Let me see if I can change to a better microphone so you can hear me better. Okay. Let's see. Let me check my audio settings. Okay. Can everybody hear me still?
Yes, we are hearing you. Perfect.
Okay. Great. Let me continue. All right. So as Abdel mentioned, I'm a developer advocate at Google. I also teach sometimes at our local community college here in Silicon Valley. And today's talk was originally called Easy Path to Machine Learning, but then I realized that the concept and the the abstract nature of machine learning doesn't make it very easy. So I can't promise an easy path to machine learning, but what I can do is I can make it easier. So that's what we're going to do today. I'm going to go through the agenda in just a moment. But this is a sort of a more of a complete talk where I'm talking about machine learning, talking about our machine learning APIs, but I'm also going to showcase some Google Cloud developer products that you're going to use alongside your interest in machine learning. So it's a little bit of a combination talk. Also, another thing is if after the talk, we have time for some questions, but if you forget or you come up with questions later, I have this barcode and this short link to an open Google Doc that has, basically a list of questions that other people have asked in different talks that I've delivered. So you can see what other people have asked and also see some of the answers. So I check it from time to time. So if you add something there later, and I don't get to it right away, just give me a little bit of time, and eventually come to it, because every time I deliver a talk, I always open this doc up for people to ask questions. Okay. The other thing is I'm going to provide the slide presentations for everyone, so you don't have to take screenshots of everything. Okay. And if you want to reach out, there's my Twitter as well too. Okay, great. So my background and my job as a developer advocate is, well, what is a developer advocate? Short question. Generally, we pretty much say it's a software engineer with social skills, which means that what we do as engineers is we speak as engineers to engineers, and we make them successful using Google Cloud and other developer tools and APIs. That's our job, is to talk directly to other engineers to help them integrate Google technologies into their apps. So it's different from using apps that Google has written, because you're the ones that are going to be the ones writing the apps. And our job is to show you how to use Google developer tools to help you accomplish your goals. So my current focus areas are on the serverless products, so App Engine, Cloud Functions, and Cloud Run. I have a few minutes where I talk about those today, but I also focus on higher education and getting Google Cloud used in schools and universities. I also spend a good amount of time on the Workspace APIs. So Google Workspace is the combination of Gmail, Google Drive, Calendar, Docsheets, Slides, Forms, and all of those tools. So I'm familiar with those. I'm also familiar with our AI and ML APIs. That's why I'm talking today. And because I have a little bit of variety in my knowledge base, I like to actually make multiple products that you see in my focus areas work well together. So that is running an app on our serverless tools that uses AI and ML APIs and maybe a little bit of workspace. Just showing that, you know, you can actually use Google as one developer product. I mean, we are one company, but, you know, every division is responsible for different products. So I try to, you know, show people that you can actually use things, you know, use different Google developer tools together. So before the pandemic, I used to travel and speak to developers worldwide. And when I wasn't traveling, I would make videos, create code samples, and make these things called code labs, which are hands-on tutorials, and then write blog posts. So that's what I do. My background is I've been a software developer for more than 20 years. Probably the most well-known thing I've built in my career is I was one of the original 10 engineers that built Yahoo Mail about 20 years ago. Outside of work, I'm a teacher. I've been teaching for, actually, my teaching career is longer than being an engineer, so it's kind of interesting. But it's a passion of mine that I like to do on the side, and I'm also a member of the Python community. But this talk is not about me, it's about you. So what does the agenda look like? So obviously, we're going to start by introducing what machine learning is. And at the end, I'll give you some inspirational apps and a summary, but there's also a lot of things we have to do in between before we actually get to the end. So the main idea behind the talk is that big data is everywhere now. And even though the concept of, you know, AI and ML have been around for, you know, at least 60 years, they were never really mainstream because we never really had the amount of volume of data that we have now, so that we needed it in mainstream application development, programming, and things like that. But that is the case now. However, being able to you know, use AI and ML the most efficiently requires a certain level of mathematics and statistics, and not everyone has this. And because of this, this makes AI and ML a little bit more challenging. So there's a slightly steeper learning curve. However, using APIs that are powered by machine learning help ease this burden, because as a developer, if you can call APIs, you can actually use machine learning and start to learn about things, and you know, and study, you know, as part of your studies. And you know, at some point, if you're continuing in this field, then you will develop enough knowledge to understand exactly how to do it. So the first step is to figure out what it is, to learn the vocabulary and build up those skills. Maybe review some of your university math, and that will all help you get started with it. And of course, Google, as a, you know, as a cloud vendor, we provide these AI ML tools for people of all different skill levels, and many other tools to help you learn the concept. So sorry, it got cut off there. Okay, so what else are we doing? We're going to do a quick introduction to what Google Cloud is, discuss how to use Google APIs. Of course, we'll look at all of machine learning APIs, and then other Google Cloud tools and APIs that you may use in conjunction with, you know, in doing machine learning. Okay, so that's really what's going on. So this first part, what is machine learning, has nothing to do with Google. It's just machine learning in general. So caveat is that I'm not a data scientist. I'm a developer like many of you. So your journey is also mine. However, I know how to call APIs. And even if I know nothing about machine learning, I can actually get something done. I can actually use machine learning without having to know too much about it. Okay, so my job is to sort of like inform you on some of the things that you should know before you get started, some of the terms, some of the, you know, vocabulary, so that you already start getting comfortable with it. And by the time we're done today, you should have enough confidence that you can actually get started doing this on your own. Okay, that's really the main goal. All right, so what is machine learning? Machine learning is, you know, AI, artificial intelligence, machine learning, and basically the idea is to make computers smarter, not really computers, mostly your software. You know, it's to make your software smarter so that we can understand more and get more insights than we were able to do it without machine learning. Okay, so first question I always ask people is, how many of you can tell the difference between a dog and a baked good like this? In English, this is called a muffin. I'm not sure how you say it in Arabic or en français. But in America, we call this a muffin. It's a baked good and it's wrapped in colorful paper. So how many of you well, I guess it's hard for me to see hands because usually I'm doing this on stage. How many of you can tell the difference between a dog, a small dog like a puppy, and a muffin? Most of us would say yes, we can tell a difference. It's very clear, right? A puppy, a dog is an animal. It is alive. It has eyes, you know, 2 eyes, a nose. And then a muffin is sort of round. It looks like a volcano or a mountain. You can eat it, and there's sometimes colorful paper around it. So we as a human can tell the difference because in our lifetimes, we would have seen you know, a good number of dogs and maybe a good number of muffins as well too. But what's more challenging is if you ask a computer program to tell the difference between a dog and a muffin. It's harder for your code to look at this image and tell the difference, right? Not as good as you, because as a human, you've been trained throughout your lifetime. You've seen many dogs, different types of dogs, maybe different muffins, many different types of muffins. So you know the difference between the two. But that is not always the case with computers. With a computer, you generally have to come up with a set of rules like, you know, a dog looks like something that has fur, it has 2 eyes, it has a nose, and a muffin doesn't look like it's alive. There's no physical, you know, other than it looks like a mountain or a volcano and things like that. So those are kind of generally rules that you would use to apply to try and understand the differences between the two, right? But as a programmer, your challenge is to write the best possible code that can most likely or more likely identify the difference between a dog and a muffin. All right, so let me ask you the question one more time. How many of you can tell the difference between a dog and a muffin? Okay, what happened? I just changed the slide. And by changing the slide, thank you. By changing the slide, I made the problem a little harder, right? As a human, it's harder to tell the difference between a dog and a muffin now, right? Okay, so imagine how much more difficult. I already said that, you know, doing this picture, these 2 pictures is already hard for a computer. Okay, imagine how much more difficult it is for a computer to recognize the difference between a puppy and a muffin here, right? Okay, so the rules that we had before, like, oh, it has 2 eyes and a nose and it's furry, those rules don't necessarily apply that well to this data set, correct? Right, so you can't use rules like that, and none of these look like mountains or hills. Maybe perhaps you can recognize paper. Maybe this one has paper, this one has paper, but then you'll only have identified two, or this one too. So maybe you have identified 3 muffins. There are some muffins that don't have the paper, right? And some of them have features that look like 2 eyes and a nose, right? So you can't just use rules. That's the bottom line, okay? So machine learning is really rules as well as experience. Like, this is a dog, this is a puppy, this is a muffin, this is a dog, this is a puppy, this is a muffin, this is a dog, this is a puppy, that's a muffin, right? And you have to have hundreds or maybe thousands of examples of muffins and puppies before you can really understand, you know, or be able to make an accurate prediction on which one's a dog and which one's a muffin, okay? All right, we're going to throw cats in here too. So I know there's some cat lovers, so we don't want to leave cats out of this picture. All right, so here's a slightly different question, which is it a cat or a dog? Okay, it's probably a more traditional, more traditional question. So a neural network is basically, you know, a software layer or just a layer where you're getting signals that indicate if it is a cat or a dog. And there could be more than one signal, and you go through multiple layers. Like, you answer some questions like, does it have this feature, does it have that feature? Once you get past that, you'll have a certain, you know, amount of signals that say this is a cat, certain amount of signals that say this is a dog. Then you go through another layer that asks sort of a deeper question, and then a deeper question, and then a deeper question. And maybe at the very end, when you're done, all of those, you know, all the different possibilities of what this could be will boil down to just one. Okay, so the more layers you have, the deeper your neural network is, because this is how our brains work, actually, or a simulation of how our brains work. Okay, and so what's happening is you have to go through this process. This first step is called the training. So you see lots of pictures of cats, you see lots of pictures of dogs, And it says they're labeled on purpose so that if you take this photo and you flip it over, you can see it's a dog or a cat. So you know the answer, right? You're getting answers. You're getting pictures and you're getting answers of what it is. Once that's done, then you can give another picture where there's no label. You don't know if it's a cat or a dog, and you send it through all of this, all of these layers. And hopefully at the very end, you'll actually have an accurate prediction. Okay. So the first part is you need to train your model. So that's the terminology. This is a model. Okay. To recognize many pictures of cats, many pictures of dogs. Okay. So that you have something in here that's really robust. That's another word I'm not sure how to translate to Arabic or Francais. But the better, the more sort of like the smarter, the more experienced your model is at learning cats and dogs, the more likely that when you give it a new picture for something it has not seen before, that you end up getting the correct answer out of it. Okay, so that part is the testing part. All right, so that's in essence what machine learning is. So lots of tools use it. Google Translate is one, so this is pretty popular. If you need to translate things to Arabic or Francais, you would go and use Google Translate. However, it used to be the case that before 2016, Google Translate just used, words and definitions to help do the translation, but that's not the smartest way of translating. A better way of translating is listening to all of you speak Arabic or Francais every day, learning your vocabulary, and then hearing the equivalent in, Anglais, English, and then kind of matching them. So starting in 2016, you can read this article, which basically says, it tells you that Google Translate switched from a sort of more specific, example model to more, using AI and ML based on patterns and thousands of phrases that people have spoken or used to speak. And so the translation is more accurate now. It's still not perfect, but it's much better now than it was when Google Translate first launched. Another example is Google Photos. It's great that we have the Google Photos app. It's great that, it helps us organize the pictures we take on our Android phones. But did you realize there's actually a search bar? Did it ask you what's in your photos first? Did you train the Google Photos machine learning model so that when you type dogs, it actually brings up pictures of dogs that you took, right? No, it's all built in. So Google Photos has its own machine learning model that has been trained across thousands and hundreds of thousands of dogs. So then when you type dogs in your Google Photos search bar, it will do its best to try and find dogs in your photos, okay? And in general, the number of Google products that has use of machine learning has, it's like we call this a hockey stick for a sport. When you're playing the ice hockey, there's the stick and it just goes straight up like that. So we stopped counting after 2019. It's just too high, right? So we're adding machine learning to many of our products. And by the way, it's not just Google. There are a lot of companies out there or NGOs, non-government organizations that are doing it to help humans. For example, this is called the Global Fishing Watch, and it basically represents where are humans fishing. So more than 1 billion people on this planet eat seafood. Unfortunately, 85% of all the waters on Earth are either under capacity because they're at the maximum limit for fishing or illegally being overfished. So instead of letting all the fish have a good population and things like that, we're doing too much, or they're recovering from being overly fished. And it turns out that 1/5 of it has been illegal or undocumented or unregistered fishing. So humans doing this is not scalable because we cannot keep track of, as humans, we can't keep track of every country, every boat, every fisherman that's on the waters. So there's an organization called Global Fishing Watch. You can go and check out the latest version of this fish. This is an older screenshot of over time that shows fishing activity on this planet. It has machine learning classifiers that can identify the different types of ships because not all ships perform fishing. right? So it can identify like cargo boats, tugboats, sailboats, and fishing boats, of course. It knows about the size. So if it's very, very large, it's probably not a fishing vessel. It can also recognize the type of gear that is used to do fishing with. And it also finds where these boats are moving. So this is one use of machine learning to help the earth and to help maintain a good balance of having seafood in the water, because we're dependent on sea life for human life to survive as well too. So that's one example. Another example is a Japanese farmer is trying to organize all of the cucumbers. Again, I don't know how to say this in Arabic or Francais, but it's a vegetable. It's green. That's crispy. You just generally put it in salads. But a Japanese farmer is trying to identify good cucumbers, bad cucumbers that should not go to customers. And if it's a good cucumber, it should find the right size box to sort them according to size, large to small. Okay, so if you go to this link and read this blog post, you can see a small video of how this thing works. And then similarly, if you're, making, baby food, and you're, making, you're a cheese manufacturer, you don't want to send bad food, in children's, you don't want to put bad pieces of cheese in children's food packaging. So you can read this article and see this YouTube video as well that shows a little bit about how this company uses AI to recognize, something that has been spoiled or should not be eaten. Okay, so these are also examples of machine learning, not Google, but using Google technologies and helping humans in some way. Okay, all right, so traditional way of programming that we've done all this time so far is we took a bunch of rules, we have our data, and then we process the data using those rules and we get answers out. Okay, that's unfortunately, remember, that's not how machine learning works. We can't do it that way, because if you just have rules, then that's not good enough. You need to have experience as well. So with machine learning, you have to take that data as well as the answers. Is this a cat? Is this a dog? Is this a muffin? And then you build a model around it. And then what happens is you get a model, and really that's just a set of rules that says what makes a dog, what makes a cat, what makes a muffin. Okay, so it's a little bit inverted in some ways. Okay, so given that this is machine learning, so repeating that basically. So these rules are basically a model. And so what happens is this part of where you're building this model, building this set of rules, that's called the training phase. When you're done with that and you want to try it out, okay, that's called the predictive phase or inference phase. Predictive is easier because that's a more common English word. Inference is a little harder, but if you want to show your sophisticated English speakers, then you can use inference as well. And this is where you take new data that your model has not seen before, and you ask it, based on the rules here, whether this is a cat or a dog or a muffin. Okay, so two phases, training phase and testing, inference and predictive phase. Okay. All right, so that's your general intro to machine learning. So I hope you guys understand that. So now we're gonna get through all the product stuff. So introduction to Google Cloud, Cloud Platform, Google Workspace. It used to be called G Suite, and our tools and APIs. So Google Cloud is sort of like a large organization. We make two well-known products, product groups actually. So Cloud Platform that has all of our cloud developer tools. And then we also have Workspace, which I already told you was Gmail, Drive, Calendar, Docsheet, Slides, and a bunch of other things. What's interesting is people think that the left side is for developers and the right side is for end users. Mostly that's true, but not 100% true, because behind most of the Workspace applications is an API. So you can actually code these too. It's just that we don't talk about it that much because not everybody, we have more people using the tools, obviously, than people coding them, but that doesn't mean you can't do it either. So just be aware both sides are for developers. Okay, so specifically on the left side, we want to focus on the machine learning building block APIs, because these are the ones that you're going to use to help you get started. All right, probably the easiest one you can learn is Google Translate API, because it's, for you guys just have exercises translating things from Arabic to French and vice versa, right? Or translating things to English. Okay, so you'll probably, this is basically the API for Google Translate. So you can actually use this, okay? And I don't need to explain to you how to use it. You probably already know how to do it. You give it some phrase, you give it source language, destination language, and call the API with all that, and you get the output. Okay, pretty basic. Some of these other ones are a little newer, so I want to tell you about them. So what the main idea behind these and why you should start with these is because these are already pre-trained. There are already models behind all of these that have been pre-trained by Google scientists, and they work pretty well. Okay, they use the same technologies as what is in Google Translate, Google Photos, as well as the Google Assistant. They require no knowledge of machine learning. Again, if you can call an API, you can use machine learning. And these are the APIs. There's 6 of them. It looks like 5, but there's actually 6 because with speech, there is an API that translates speech to text and another one that goes from text to speech. So I'll tell you about these as I cover them. Okay. This link is a little outdated now because we threw them all into a larger product group called Vertex AI. So that's what you'll see when you start looking for these things. But I think this slide links to the older version of the page. I like to separate these out because not everyone's ready to jump into the whole Vertex AI product group yet. These are just sort of like a small subset of things that you can use without knowing much about AI. So when you click on this link in the PDF, you can see the link I have down at the bottom there that it's a little longer because I'm grabbing this from the web archive. Okay, but anyway, that's what the page used to be. So anyway, so let's talk about these. Where do they sit in the full spectrum of all the things that Google provides? So from left side to right side is you're moving towards becoming a data scientist left to right. Or the other way around, you're a data scientist, a full data scientist and researcher on the right side, and you're moving to the left, you're becoming an app developer. So these fall into the left side, which are purely app developers. You're not typically a data scientist, where you're using pre-built, pre-trained models. That's this. If you want to start doing something, and I'll tell you a little bit about AutoML momentarily, but there are sometimes these aren't good enough and you need to customize it some more. That's what AutoML does. When you're ready to use our full product line of AI ML tools, that's when you look at Vertex AI, because then this is where you start using our tools, and then maybe you're using some open source SDK like, Keras, TensorFlow, PyTorch, scikit-learn. And then when you're all the way on the right-hand side, that's all you're using. Those are all the tools. You have to manage your own training infrastructure. Maybe you don't want to manage your own machines. Maybe it's too expensive to go and allocate so many GPUs to help train your models. So then you slide left a little bit and you take advantage of Vertex AI because we provide you with the infrastructure that you need to do building and training and serving of your models as well too. Okay. So anyway, so I'm focusing all the way on the left-hand side, but you can keep on learning towards the right as you get more into this field. Okay. All right. So what are Google APIs? How do you use them? So just generically, Google makes a lot of applications. You probably use a bunch of these. All right, search, Android, YouTube, Chrome, Gmail, Drive. Most people know Google for these things, but you can't wait for Google to write every single app for you, right? As a developer, your job is to make your company or yourself successful. And so what you do is you write your own apps. That is something that we haven't written yet, right? But we also don't want you to have to reinvent all of the technology from scratch. So we provide APIs to help you work on your next mobile app as well as your next web app, or the other way around, okay? Because you probably have to do both anyway, all right? So that's what our APIs do, allow you to write code integrating Google technology so that you don't have to invent it from scratch. Don't reinvent the wheel, basically. All right, so how to use Google APIs if you're new. Since you're in a GDG, I'm going to assume that many of you already know how to use Google APIs, but basically, if you're new, you go to the Cloud Console, you log in with your Google or Gmail account, you create a project because every application has resources it needs. So a project is just a container that says, oh, for my application, I want to use this API, and please put it on this credit card so that my company pays for it. So that's what a project is. It's a container for defining all the resources that you use in one app. Then you turn on which APIs you want to use, right? I want to use the AI ML APIs. I want to use the Google Sheets API. I want to use Google Cloud Storage. You just pick all the APIs you want to use. And these are not enabled by default because you can't possibly use them all because we have so many. So you have to, we turn on a few by default, but for the rest of them, you have to just turn on the light switch. If you're not interested in using them anymore, you can turn off the light switch as well. Okay. After you do that, then you can enable billing. Sometimes when you're turning on APIs that require a credit card, it will actually ask you to submit your billing account. So whether it's a credit card or using the free trial or whatever. So yeah, so most of the cloud APIs require billing. The workspace ones do not. Maps does, YouTube does not. So some Google APIs require billing, many of them don't. Once you're done with that, then you're ready to start using an API, and many APIs, most APIs have a client library, so you have to go and find those, download them. They help you use the API in an easier way. You have to create and download whatever credentials. We're trying to, not have you download the credentials anymore, maybe just create them and specify them somewhere. Just because when people download credentials, sometimes they get exposed accidentally, or some people accidentally upload it to GitHub. If you upload it to YouTube, you're in really big trouble. But we're trying to make it easier so that you don't have to have, the credentials directly on your device. Then you write your application, and then you run your code, which may need authorization because you have to make sure that those credentials work. And there's some costs. So for cloud platform, it's usually pay per use. So whatever you use, you pay for. Workspace is generally paid for by subscription. And so your API usage is free based on your usage and your subscription that you sign up for. This includes Gmail, normal Gmail accounts. So for all of us who have Gmail accounts, we also have, free access to Workspace APIs. That's why we don't really have to pay for them. Okay, for GCP, if you are thinking about using it or trying it out, there's a free trial. It's $300 for 1 quarter. But if you're new, I wouldn't do that right away. I would sort of come up with use cases first and prototype your apps. Don't start the free trial right away. The reason is because that starts the 90-day clock. Once the 90 days expires, you can't ask for it anymore. It's only a one-time thing. So if you start it today and you go, I'm going to research AI/ML sometime soon. So you wait a couple of weeks, you start looking at it, and then maybe you start using it and stuff. And then pretty soon 90 days is gone, right? So don't really start it until you're ready to really start using it. There's also a free tier, and what we call an always free tier. So that means many of the products, I wouldn't say most anymore, but many products have a free tier. In other words, it's like free usage for a day or a month, and you have to actually go above that limit in order to get billed for it. Okay, so you can learn more about which products have a free tier and what kind of free tier you get by going to this giant link here. Okay, so once you're at the Cloud Console, the things that are important to you are, so on the left-hand side here are the products you're going to use, at least on the cloud side. So you go down and you pick, maybe some of their AI/ML APIs or things like that, or what kind of databases are you using, what kind of compute you're using, security, networking, and all that stuff. Then you also have billing, so that's also important. Also IAM and admin. So IAM is identity and access management. So this is all the permissions, and also adding users. So if you're doing a project with more than one user, you want to add them and give them some permissions in your project. You can do that there. And then most importantly for us, this is the API manager. So this is where you enable the APIs you want to use, like the AI/ML APIs. So once you go to this, it's also called the developer console, by the way, and there's a short link to it. And so what happens is you get to a dashboard, and the dashboard shows you what you see on this screen here. It gives you a graph that shows you what kind of traffic your app is getting, a graph of the errors that your app is generating, and basically the rough average response time it takes for your app to respond to your users. And then down below that is a list of all the APIs that you've turned on for your project. So this is basically all your application statistics on this page. The second page is a library, which I'm not showing a screenshot of, but you got to click the library link here. And then you'll get taken to another page where this is where you enable and disable Google APIs. You get a search bar, and you can, type in, translation. Once you type that in, it starts showing up. You click on it, then you enable it, and then you can use it. Okay, so it's basically a search bar. You look for the APIs you want to use, and you turn them on if you're interested. Okay, and then the last one is the credentials tab. Again, that's not shown here, but that's where you attain the different application credentials that you need. We have 3 different types of credentials: API key, OAuth client ID, and service account. Most likely, if you're using cloud stuff, you're using service account. Okay, if you're using Workspace, that's mostly going to be OAuth client ID. If you're using Google Maps, it's pretty much API key. So it all depends on the APIs that you're using. So if you want to see a full video on how to use a developer's console or the API manager, you can take a look at the video that I have here that I made a couple of years ago and get more information, because I don't have time to cover all that today. All right, all the demos, all our APIs, you can use many different languages, so whatever language you want. My demos will be in Python and JavaScript because they're more common for web apps, and also I can write code with fewer lines of code. So mostly Python, some JavaScript. So for cloud APIs, you're going to be going to this link, which is all the cloud client libraries. And then Google Maps has their own set of client libraries. And then this one is more generic if you want to use the lower level client libraries, because not all products have their own product client library. So you have to use the lower level client library. So anyway, those are 2 links for you. Basically, how our APIs work is that they all work in a request response workflow. So your application makes a request to a Google API. We first have to check that you have the right credentials. If you do, then the API services your request and then responds directly back to your application. So very client server like. All right, you send a request, then we get a response. Okay, so what are these machine learning APIs? So the first one I want to talk about is Cloud Vision. So Cloud Vision lets you understand the content of an image. It will let you identify, detect objects and labels. It can also read text, identify famous landmarks, company logos. It can also recognize facial features. This is different from facial recognition. It can't recognize you or your face, but it can tell if you're happy, you're sad, you're smiling, things like that. It also knows how to recognize well-known products. And also for adult content, explicit content, it also recognizes that as well too. If you want to learn more about the Cloud Vision API, you can go to its homepage, and I think there's a demo that you can try there as well. So I'm just showing you sample code. So this is in Python. So I have an image that's sitting in cloud storage, and I'm importing the Cloud Vision client library. So the way you start using it is you create a client, an API client, and then you say, okay, well, I have an image here, and here's the link to my image. I want you to detect things that are in this image. So you make this call called label detection, and then what comes back is a response. And then I just print it out to the user. What do I see in this picture? Draw a blank line. And then for everything I see in the picture, tell me what it is that you saw in this picture, and then give me the confidence score. What is the likelihood that this object appears in this image? Okay, so for this picture, you kind of get an idea of what it is. It's going to be a picture of a market in the city of Shanghai. And this is what it looks like. So this is the image that goes to the API. And when you run this application, the output, labels and confidence score, and then a blank line. That's these 2 lines here, or these 2 lines right here. And then the response, I'm just going to go through a for loop here of what it saw. So people, it sees people, 95% chance there's people in this picture. There's a street. There's some sort of transport mode, actual transporting vehicles. It is a snapshot in time. It is an urban area. There's infrastructure, there's a road, and there's also pedestrians. So this is part of the Cloud Vision API code lab that I helped edit. I didn't write it. I can't take the credit for it, but you can try it here, where you actually can learn how to use this feature and 3 other features of the Cloud Vision API if you want to get started using this one. Another API is called the Cloud Natural Language API. So this reveals the structure and meaning of text. It can perform sentiment analysis, content classification. It can extract entities like Lebanon, your flag, Tripoli, Beirut, Paris, London, the Eiffel Tower, and things like that. It can extract entities. It also can do syntactical structure analysis. So this is the noun, this is the verb, and it supports different languages. And then there's a home page there. So a demo of this one is going to be a demo using this text right here that you see here, so you can slowly read that. I import the natural language API. I create a client for the API. Are you beginning to get there's a pattern here? This is how you use all our APIs. You have to import the client library, you create a client for the API, and then you start using it. So here I have a document, okay? Print out what the document is, and now I'm going to perform sentiment analysis. That is asking, is this positive or negative? So if you read this phrase here, in your head, try and determine whether you think this is positive or negative. Okay, and then I'm going to print it out here, what the answer is. Then the second thing I'm going to do, so this demos two features of the natural language API. This is content classification. What kind of content is this text most likely to be? And show the confidence score for that too. Okay, so for this text, positive or negative? What do you guys think? Probably most people say positive, right? Because of this word here, users love their new Android phones. The word love is positive, right? So let's take a look at the answer. The answer is, here's the text, here's my sentiment. The score is positive, and that's correct. If the sentiment was negative, this would be a negative number between 0 and 1. If it's positive, it's between 0 and 1. But the score is kind of low, even though it's positive. But the magnitude seems to be higher. Why is that? The reason is because it only found one word in this whole phrase that indicated this was positive. That's why the score is low. The word is love, right? Is love a strong or a weak word? It is a pretty strong word. That's why the magnitude is higher. If I changed love to like, the score will probably stay the same because there's still only one word that it could use to make it different, to determine if it's positive or negative, but the magnitude would be lower because like is not as strong as love. And then if I had more sentences that said, oh yeah, people said they love their phones because it has such great features, I'm really happy with my phones, then the score would go higher because there's more evidence that this phrase was positive. Okay, everybody understand that? Okay, and then as far as categories go, it's 76% chance it's internet telecom related, 64% chance it's related to computers and electronics, and 56% chance it's from a news article. Okay, so that's how you use the natural language API. The next ones are speech. So the speech APIs help convert speech to text and text to speech. By the way, of course, I don't have time to demo every single API. So at least I'll tell you about them. All right. So I don't think I have a demo of this one yet. So the way this works is if you have audio speaking and you want to convert it to text so that your application can process it, you use a speech to text API. If you have some text already and you want to put a voice behind it, okay, then you would use the other one, the text-to-speech API. So it'll take text strings and it'll translate them to audio files. You can choose male or female. You can choose if they're a native French speaker, Arabic speaker, German speaker, English speaker, different types of speakers. So you can choose lots of different voices, okay, with text-to-speech. So that's that API, those two APIs. The next one is the Cloud Video Intelligence API. This is like the Vision API, except that instead of one image, it can scan all of the frames of an entire video. So basically, you can make a video searchable because now you can say, oh, where does a picture of this dog walk into the picture? So you can look for the first frame where it shows up. So you can make a video searchable. You can track objects. You can check when a camera angle changes, as well as read text that's in a video. So that's the Video Intelligence API. Then the last one is Google Translate. The Cloud Translation API is the API for Google Translate. Okay, and we already talked about it uses neural networks. So yeah, a homepage for that as well as Video Intelligence. Okay, so now let's talk about these 5 APIs are good. Okay, but they may not be good enough for you. So, for example, the Cloud Vision API, remember, it has a pre-trained model, so you don't have to go and train it yourself. Okay, but it is limited in the type of training that it has. For example, it knows how to recognize a cat, a dog, and a muffin, but maybe you work in the medical field. Maybe you have a bunch of medical X-rays or CRTs or MRIs. Sorry, X-rays, CAT scans, and MRIs. The Cloud Vision API was not programmed to recognize medical images. Or maybe you work in construction, building buildings and architecture. It is not trained to read blueprints. Maybe you are a botanist and you study flowers. The Cloud Vision API knows what a flower is, but it cannot tell you necessarily what species it is, because there's so many species of flowers or fruits or vegetables or fish or dogs or cats. It'll tell you it's a dog, but it may not be able to tell you the kind of dog or the kind of vegetable it is, right? So in that case, you want to use the Cloud Vision API, but you want sort of like a Cloud Vision API that's been customized for your data. All right, that's what AutoML is. AutoML by itself is not an API. It is an enhancement on existing APIs that I just talked about. So Cloud Translation, Cloud Vision, Cloud Natural Language, Cloud Video Intelligence, okay? So that you can actually create customized versions of these 4 APIs. So, you know, Cloud AutoML Vision, AutoML Translation, AutoML Natural Language, AutoML Video Intelligence, so that you can provide our model extra data that belongs to you to help customize that API for you and your data. And then when you use it, you can get, you know, information on the species of flowers or the medical images that you're researching, all without having to know too much about machine learning other than you have to train our model. You don't have to make your own model. You don't have to use TensorFlow. All right, you don't have to have significant math skills. You really don't have to have a lot of expertise at all. It's just one step up from using our APIs, because now you're trying to customize our APIs for you. The last one is a little bit different because there is no API for, you know, this looks like spreadsheets, right? It's basically structured columnized data, rows and columns of data. There's no such thing as an API that does rows and columns of data, but you may have rows and columns of data that you want to put a model on top of. For example, what is the, what kind of job do you have? What is your profession? Do you live and work in Beirut or Tripoli or Paris? What is your salary? So you have this all in a giant spreadsheet or relational database. And now you want to build a model on top of it. You can do that with AutoML tables. And so after you build this model on top of that data, you could say, you know what? When my child grows up, I want them to be, a software engineer in Beirut because they have the highest salaries or something like that. So you can actually ask, if I am if I work in construction in Tripoli, what is my salary expected to be, or something like that. But you have to have all the data, right? So we're just building a model so that if you provide new data with some of the columns filled out, but not all of the columns filled out, you can actually get prediction as to what the missing items are. So that's AutoML tables. Okay, so running out of time, so let's move forward quickly. So Vertex AI is our AI platform. So it has lots of stuff. It has our building block APIs, which I just told you about over the last half hour. It gives you the ability to further train these models using AutoML and other mechanisms. You can also do your own machine learning models now. So this is where you already have enough knowledge to start using PyTorch and TensorFlow, and you want to build, train, and deploy your own models. So we provide infrastructure for that. And we also provide the ability for you to actually serve your trained models publicly, all in one giant platform called Vertex AI. So you can learn more about that here. Okay, so other cloud tools that you may use in conjunction with all the ones I just talked about. All right, so these are what I call friends of AI ML, other Google Cloud APIs and services. So BigQuery is pretty interesting because this basically lets you analyze multiple terabytes of data using simple SQL and not a lot of, it doesn't take a lot of time. It responds back in seconds, even though you're looking at multiple terabytes of data, so it's huge. I don't have a good demo of lots of data, but I do have one example of William Shakespeare and all the stuff that he's written. So famous English writer, he's written a lot, even though everything that he's written is not multiple terabytes because he only had plain text back in the 17th century. Really, his data set is only like 36 megabytes, but this is asking a question that you don't want to do as a human. I don't want to write down every word that he wrote and figure out which ones he used the most. Okay, that's just not scalable for humans to do either. Okay, so instead I want to issue a SQL query to lowercase all the words so that, I count uppercase and lowercase the same. I want to sum up the word count, and then I want to group by the word and order by the count in descending order and give me the top 10 most common words that Shakespeare used in all of his writings. Okay, so BigQuery can do this. All right, so You don't see it up here, but the code that's missing on top is creating an API client. Here I'm using the API client. I want to send a job to BigQuery with this query and give it my Google Cloud Project ID, run it, and then I get the results. So how many of you people know what are the most common words used by Shakespeare in English? Yeah, I know. Everybody's going to say the, which is the right answer. Okay, 29,000 times, right? Okay, and is next, I. Okay, so this is actually the list, right? And you didn't have to do it because BigQuery can do it in half a second. All right, it's very, very fast. So very useful tool. So not quite machine learning. It does have an element of machine learning, okay? So there is something called BQML, and you can apply a model on top of the data that BigQuery is looking over. So that's very similar to AutoML tables, which I just told you about a few minutes ago. AutoML tables, like structured data, right? This is structured data in BigQuery, and you're issuing SQL calls on top of it. So BQML is very, very similar to AutoML tables. Okay, so that's the only machine learning it has. It's mostly a data warehouse tool, a data analysis tool, big data analysis tool, more than it is machine learning. Okay, but it has very interesting public data sets that you can look at. So it has Shakespeare. It also has like weather station data from around the world. It has like information on children, birth rates, and things like that. So there's a lot of public data for free. One of the interesting things about BigQuery is that everybody can use BigQuery for free. You don't even have to give your credit card. It's absolutely free. Everybody can make 1 terabyte of queries a month. What I mean by that is you can query 1 terabyte of data every month for free with no obligation, no credit cards, no billing, no anything. So it's the only cloud product that has that. So you can learn more about that BigQuery sandbox by reading the blog post and going to the documentation. We also have other data sets as well. Of course, you know, because COVID pandemic is a big thing, we have a lot of COVID data sets that you can look at. And for those of you who are in the healthcare field, we have the life sciences API, which is like genomics and things like that. And we also have a healthcare API that helps, you know, move data between systems, medical systems that don't talk well to each other. So take a look at those as well. But that's really all I wanted to say about BigQuery and all the health stuff. All right, other tools that you may want to use, cloud storage. This is all storing data, right? Cloud storage is mostly what you're going to use, but we have other storage mechanisms as well. If you have relational databases, we have that as Cloud SQL, so it supports MySQL, Postgres, and SQL Server. We also have NoSQL databases as well too. So Cloud Firestore is a combination of our older product, Cloud Data Store plus Firebase. Cloud Firestore and Firebase still exist, and you can choose between them. And there's a page on which one do you pick. And then there's also, you know, 2 different modes for Firestore, either Data Store mode, which has more features from Data Store, or Firestore native mode, which has more features from Firebase. So you have to make that decision as well. But this is our NoSQL solution. Usually when you're doing big data analysis or machine learning, your results have to go somewhere. A spreadsheet is a good place to put them. So Google Sheets has an API. Here's just an example of migrating data from a relational database into a spreadsheet. So I'm doing select star from this toy orders database, creating a brand new spreadsheet, and then writing all the data in the spreadsheet. So I made a video on this one, so if you want to learn more about that. And if you are doing machine learning, you may want to use GPUs. So we have GPUs, but TPUs are faster. And overall, they are supposedly lower cost than using GPUs. So these are basically like processing units specifically made for machine learning training. Okay. And so the last set of products I want to talk about are our serverless compute platforms. So let's kind of talk about this. And first of all, why? Okay. So we have lots of places for you to run your code. You can run it on VMs in Compute Engine. You can run it in Kubernetes. But so basically, the left side is do it yourself, do everything yourself, from the machine to the operating system to the database to the web server. You're responsible for the entire machine in addition to your code. But as you move all the way to the right, you become responsible for less things. So you're just responsible for your code at the very end. Okay, so I'm going to talk a little bit about these 3 because these are what we call our fully managed systems, where you just upload the code to these systems and we run it for you. You don't have to take care of anything else. Okay, why I'm telling you this in a machine learning talk is because a lot of times you only want to solve problems using machine learning. You don't have time to go find VMs, to get operating systems, to be a sysadmin to set everything up. You just want to start writing code and uploading it somewhere. You just want to run the code somewhere online, okay? So we do have VMs and we have big disks, but why do you need to use these? Because it makes you think about those other things. I have to do the operating system, the web server, the database server, load balancing, security, patches, and things like that. I just want to run code. So if you want compute just to run code with, you probably shouldn't do it with a VM. You should use one of the serverless tools because you don't want to think about those things, right? So serverless is kind of like a lie. You know, we don't want to say lie, it's a misnomer. Okay, it just means that you don't have to worry about it. You just worry about writing code and solving business problems. And the idea of maintaining and managing a server is abstracted away from you. Also, the other reason is there's a lot of money that's going into serverless. So corporate spend in US dollars every year is growing because people are realizing, you know what, it's too much trouble to manage VMs. I just want to upload my code and have the cloud vendor run the code for me. Okay, and so you can take a look at some of these analyst reports that show that by 2028, it's estimated that 53 billion US dollars will be put into serverless. Okay, some of these have already happened, so these are actual real numbers. And then, you know, we have to see. I have to go and check whether or not the 7.7 billion came true. I think it actually was a little higher because of the pandemic. More people started moving things into the cloud. Okay, so anyway, so we have 3 serverless products. So I just want to just show you them really briefly. Okay, App Engine is app hosting in the cloud. I'm hosting a web app in the cloud. Because all of these things made it challenging to create a web app and deploy it around the world, right? I have to worry about all these things I talked about, the operating system, web server, database server, and all these things. I don't want to worry about these things. I just want to upload code and run it, okay? And so that's why App Engine was created. This is our first cloud product. It came out 14 years ago. Is that right? Yeah, 14 years ago. It's pretty old now. So here's Python's, the world's smallest web app. So this is your Python minimally viable product. So world's smallest web app only does one thing, does hello world. So this is the Python web framework called Flask. I'm going to run this in Python 3.9, and I need the Flask third-party library. Once you have these 3 files and you have the Cloud SDK downloaded, you can run the gcloud command, gcloud app deploy, and in less than 1 minute, your app is available around the world at this URL. Okay, this is our quick start. Pretty basic, pretty easy. You can make a website. We support, of course, 5 other languages: PHP, Go, Java, Node.js, and Ruby for App Engine. If you don't have a full app and you only have little snippets of code, then you should consider our function hosting in the cloud product, Cloud Functions. So yeah, again, you don't have an entire app. You just have some short utilities, some microservices, some mobile backends. Cloud Functions also support more languages than App Engine. It does C#, C++, Dart as well too, in addition to all the languages that is supported by App Engine. Other things that it can do that App Engine cannot is it can process background events like you received a message in Cloud PubSub, somebody uploaded a file to cloud storage, somebody logged into Firebase. So you can automatically run a cloud function when one of those events happens. It doesn't have to be a web browser hitting an HTTP endpoint. And like App Engine, Cloud Functions is auto-scaling, so the more users you have, the more we scale for you. And it's always available, and you pay for when you're using. So unlike a VM, which you're paying 24/7, right? Even if you have no users, you're paying for it. Cloud Functions, App Engine, Cloud Run, all of our serverless tools auto-scale to 0. So if you have no users, you're not paying. Okay, so that's one of the nicest things about about Cloud Functions. I said Firebase because there's another version of Cloud Functions specifically for Firebase, which is our mobile development platform. So if you're writing mobile apps, you're probably going to use the Cloud Functions for Firebase. But if you're doing more cloud-oriented apps, then you'll probably use regular Cloud Functions. All right, here's your Python MVP. It's a 1-line function. There's no config file, any config files like with App Engine, so your deploy line is a little longer. It's gcloud functions deploy, the name of my function, what is my language runtime, and then how I want to have this function triggered. So this one is HTTP, so I actually have to go to a browser or curl to it like I do here, but I can make it trigger based on Firebase, Cloud Storage, PubSub, any of those that I just mentioned on the previous slide. Okay, and then just like with App Engine, in under a minute, your app is available around the world at this predefined URL. And of course, if you are going to do this for your company, you can always get a custom domain and point your custom domain to these URLs. All right, the last serverless tool is Cloud Run. So Cloud Runners are container hosting in the cloud service. So, containers are have been over the last 10 years the way people run apps. All right, so containers have really exploded, since 2010. Docker has become a generic way to deploy applications. You also don't have a lot of the restrictions that our other two products have. With App Engine and Cloud Functions, you have to use these libraries or these languages. You can't use binaries. You can't use existing, libraries, right? So containers give you the flexibility that you can use any language you want. You can have any library. You can even use binaries because you're the one that's packaging up the container that goes onto the machine, right? And Docker gives you a lot of base images you can start with. You can start with like a WordPress image. You can start with a Spring Boot image. There's a lot of base images you can start with, and really is an industry standard, like I said, for deploying apps. But, I really like serverless because it's so convenient because I don't have to think about infrastructure. I can just upload my code and run it, right? But maybe it doesn't have the language I want to use, or maybe I have binaries or a C++ library that I can't use. And also, if I write, apps, am I relying on this platform? If I write App Engine code, can I move it elsewhere? The answer is yes, you can, but not all serverless platforms from other companies are free from lock-in, okay? So the main question you're asking is, why do I have to choose between the flexibility of containers versus the convenience of serverless? Why can't I have both? So that's where Cloud Run comes in. Because it is container-based, you can have any language, any library, any binary. The only restrictions that we ask of you is what we call the contract, which is you have to leave an HTTP port open so that our app can get it, start your application, and it has to be stateless so that if for some reason your container image dies while running, and if we spawn it again and it send the same request, that it's not going to have side effects. So you have to keep it stateless. So if you can follow these two rules, you bundle your app into a container. You can do it with Docker or with Cloud Build. And then that image goes into the container registry or the artifact registry. Once it's there, you can deploy it anywhere. I can deploy it to a virtual machine on Compute Engine. I can deploy it to Kubernetes, or I can deploy to Cloud Run. And with Cloud Run, you can also do GitOps, which is push to deploy from Git. So once you commit something to Git, it can start a cascading chain of events where if you have CI, using GitHub Actions, you can run all your unit tests and regression tests. And if everything is good, then you can build your container and deploy it to Cloud Run straight away. Okay. And then the one good thing about Cloud Build Packs, which is a new feature, is that you can actually use Cloud Run without knowing anything about Docker or containers. So that's the most convenient thing. Okay. So here's your Hello World MVP for Cloud Run. It's almost identical to the App Engine version, except now that we have a container, we have to bundle a web server. Okay, and in case you forget to bundle a web server, I'm going to run the development server that comes with Flask. So that's the only reason why these extra lines are here, and that's why it's kind of grayed out, because it's typically you're not going to run these. This is also the Cloud Run Quick Start as well too, and it's available in these 10 languages, even though you can use any language you want. Okay. All right. So again, one of the secrets to doing things without Docker files is to use build packs. Build packs will analyze your code and figure out what is the best Docker file to build dynamically, and it does it for you. So for example, I have a Node.js app here. I have a Python app here. But look, the command is exactly the same. Because I am using build packs will figure out this is a Node.js app. It's going to look in package.json for all the packages I need. It will build a Docker file dynamically and create your container image based on that. And the same thing goes for Python. But you are kind of restricted to these are the languages and versions that are supported by build packs. I think maybe Java 17 is coming as well too, if not already. Okay, so that's Cloud Run. So sometimes people ask, what are the differences between the three? They're very, very similar to each other. But typically, if you have an app, you're probably going to be using App Engine or Cloud Run. But if you have a small snippet of code, you're probably running Cloud Functions. Okay, that's typically the difference. App Engine is our first generation set of cloud serverless products. So generally, we kind of recommend people use the second generation, Cloud Run and Cloud Functions. But Cloud Run is so similar to App Engine just because the only difference is that you're bundling it up into a container, really. Okay. All right. So, and if you want to learn about all three, I have a sample app. You could probably try it out because it actually is a demo of Google Translate as well, the cloud translation API. So you can grab the source code and modify it to, go between, Arabic and French or English. So you can fool with it. The reason why this is useful is because you can actually deploy this app to App Engine, Cloud Functions, or Cloud Run, and you don't have to change the code. The only thing that changes is the configuration. So this is a tool to actually help you learn the differences between the three. But it's not like they're so different that if you pick one and you decide later on you want to move to another one, if you write your code in a flexible way like this app, you can pretty much slide it over to a different serverless tool. Okay, so that's that. All right, and then the last one I don't have time to talk about because we're out of time. So AppScript is basically serverless, but it's on the workspace side. So if you do a lot of work with Drive, Calendar, Docsheet, Slides, this may be better for you. So here's an example of how to program Google Sheets. This is a one-line function. I just broke it up into 4 lines, but this is really just one line where I'm going to get the current spreadsheet, get cell A1, and then put Hello World into it. So I save it, run it, and boom, I have Hello World here. And it's pretty exciting because you didn't type this, right? You ran some code and it happened automatically. So I have a whole video on that if you want to learn more about it. But that, Hello World is pretty basic. It doesn't have real data. So here's something that's more real data, right? It's an actual address. What can I do with this? Well, instead of 1 line, I can blow this application up to 4 lines. All right, what can I do with this? I can go and grab that same sheet. I can say cell A2, instead of setting the value, I'm going to get the value. Okay, here's A2, get the value, save that in address. Then I'm going to say, hey, Google Maps, can you make me a new map and put a marker or a pin on this map at that address? And then line 4 is, hey, Gmail, can you email this map to my friends so they can meet me here tomorrow or something like that? So 4 lines, touches 4 different Google products. Doesn't even have to be Google products. It's just that this sample uses Google products. I can use JDBC to talk to relational database. I can use URL fetch to talk to some other service that's available on my network or online. Okay, so you can start developing interesting things with this, right? So I also made a video on this one. So where can you take this simple example? You can take it to where, oh, maybe I want to visit all of my customers in New York. Okay, or maybe I have a monthly a book club or monthly user group meeting like a GDG. So I can use I can use AppScript to write an app to tell people where, it uses the Maps API to tell them where is the next meetup. It will put something in their Google calendars. It will send out a reminder using the Gmail API where, when is meetings coming up on Thursday, this Thursday, please come. So you can use lots of different Google APIs to sort of like make these things happen. So why did I tell you about all that stuff, right? The reason is because in these 2 examples here, I'm going to show you how to use everything in one app. Okay, so my colleague wrote this app that adds custom intelligence to Gmail by analyzing workspace data using GCP. So what did he do? He says, oh, I get a lot of email, and even though Gmail filters out all my spam, maybe with all my non-spam email, I still have only certain messages that I really, really care about. So, and maybe, they're going to be pictures of birds. So I only care about emails with pictures of birds. So let's just use that as an example, okay? So what did he do? He wrote an application so that every time a new message comes into his Gmail, that automatically notifies our cloud messaging system, Cloud PubSub. Hey, a new message has arrived. Send the message to PubSub. What does PubSub do? It can notify and trigger a Google Cloud function, which I just talked about. The Cloud function will then take that message from PubSub. It will extract all of the images from that email. It will send it to Cloud Vision, ask to analyze the contents of it. And if bird is one of the categories that comes back from Cloud Vision, then the Cloud function will go and call the Gmail API to star that message. So without running any code explicitly, the next time he logs into his Gmail, he can see that there's some emails that have pictures of birds in them because they're starred. Okay, not a really useful example, but it's just an example of what you can do when you sort of like mix and match different Google technologies together and use the power of ML to help you accomplish something. Okay, then here's some more information about how you get Gmail to notify PubSub, how do you get PubSub to trigger a Cloud function, and then there's a blog post, and then you can also get the code at this link here. The last example is this big data analysis of slide presentation. So I did this example to show you how you can access GCP tools from Workspace. So I say that big data is very common every day. Everybody has big data now. And of course, we have great tools like BigQuery to help us analyze that data. But look at this. The output is either in this website or download as CSV. Do you really want to give your CEO this a CSV or your CTO a CSV? That's not good. That's not visual, right? You're almost done. You're 80% done. It's like these stairs. You can use these stairs, but it's 80% done, but it's not visually appealing. So this is not pretty to look at, even though you're mostly done, right? So I say this is the same thing. The data looks like these stairs. Why don't you make it more useful for your manager, all right, or your boss? Put it in a spreadsheet. Bosses love spreadsheets. And if you're using the Sheets API, you can tell the API to make a chart based on the data that you dynamically imported into the sheet. And then if you're going to make a presentation to your boss, you might as well put it into a slide, right? Put the data into a slide, put that chart into a slide. In fact, build the entire slide deck so I can go present to my boss right away. You know, why do just the 80% of the work? Why don't you do the last 20% and make your data presentable? So this example is written in AppScript. I'm sitting at my console. I click the run button. It calls BigQuery. The results come back. Instead of putting it in CSV, I tell it to go into a sheet. I tell the Sheets API to make a chart. I create a brand new Google slide deck. I import the chart and the data into the Google Slides. And now I have gone from big data analysis all the way to boss ready slide presentation. Okay, this example uses AppScript, BigQuery, Sheets, and Slides. You can build this app line by line. I created a code lab for you. I also made a video on it. Here's the source code, and I also presented this at Cloud Next. But the main idea is you did 80% of the hard work. Do the final 20% and make your data presentable. By the way, this code sample, if you take out all the blank lines and comments, it is less than 100 lines of JavaScript. Less than 100 lines to finish the last 20%. Okay, and that is it. So to wrap up, machine learning is solving harder problems by making computers or software smarter. My colleague said that it's basically using data to answer questions. This is a cat, a dog, or a muffin. How do you do machine learning? You collect a lot of data, you build and train your model, and then you use your model to make predictions on new data. Do you need lots of experience to get started? No, because we have pre-trained models ready for you to use using our APIs. Do you need to do training? Well, if you have to do a little bit of training, consider using AutoML, where you're using the same pre-trained APIs, but now you're customizing them to your data set. And then when you're ready, then you fully understand how to do machine learning, then you get all the math background that you need, then you can go and use an open source library like PyTorch and TensorFlow to go and build and train your own models and then serve them as well too. Okay, so we have lots of links for you for workspace stuff because I covered some of that. Here's some more GCP links. What your next steps are is to investigate the ML APIs. And then when you're ready, move on to AutoML. If you want to get your hands on a cloud AutoML code lab, cloud machine learning code lab, sorry, you go to gcplab.me. That's all the code labs that are for cloud, okay? And then you can also look at Kaggle and Colab as well too for more machine learning and training stuff. All right, so if you are doing machine learning, you're a data scientist, you probably use Jupyter Notebooks. We have 5 different products that use Jupyter Notebooks, so you can take a look at those. And here's a fun game. So if you want to teach machine learning to your colleagues or your children, this is a very fun game. If you go to quickdraw.google.com, what happens is it presents you 3 objects, and you have to draw it in under 20 seconds so that the Cloud Vision API recognizes the thing you're trying to draw. So it's pretty fun. Another one that's more interesting, less of a game, but it's an explorer, is this demo, where you can go through this entire universe of things like sports and flowers and animals, and you scroll in and out. It's like a 3D galaxy that you can investigate, and you can kind of scroll in and pick one particular image, and it'll tell you what the Cloud Vision API sees. So both of these are Cloud Vision demos, but they're very interesting that you can try out. Okay, and then Google has other APIs that you can look at. So we already talked about Workspace and Firebase, which is a mobile development platform. If you want to build beautiful dashboards, data visualization tools, look at Data Studio. It's kind of merged with our Looker product now. If you want to build voice-driven apps, look at Actions on Google, where you can build apps for the Google Assistant, and it uses Dialogflow. YouTube has APIs, Maps has APIs. And if you want to build apps that work on Android and then iOS and the web with only one source code, then you look at Flutter, because it's very popular now. Nobody wants to write a web app, then write an Android version, then write an iOS version, because you don't have the developers and you don't have the time. So with Flutter, you can actually do it with one source code. Okay, so it's kind of like React Native, if you ever use that as well too. Okay, so take a look at that. And that is it. So that's me. That's my Twitter handle. My daughter says hello. She loves to draw these Japanese anime characters. Here's a link to the open Google Doc again, but the slides. Actually, I don't think this is the right barcode, but copy down this URL or take a picture of this. Actually, just take a picture of this. This might be right, actually, this one. Try the barcode, see if it works, if it's easier. Otherwise, type in this short link to get to the slides. I also gave this same talk using older slides, maybe about a year ago. So take a look at that. And if you notice this, the progress bars down at the bottom, PowerPoint and Google Slides don't have a progress bar, so you don't know how far along you are. But my colleague wrote a progress bar application using AppScript, because AppScript, you can build add-ons. And so this is a Google Slides add-on that basically is a progress bar to show you how far along in your slide deck. You can see the slides. Well, too bad this one's too long. So you can see this progress bar going to the right? It's going back to the end. So anyway, so these are 3 links that you should probably have. So if you want to take a picture of one slide today, this is probably the best one to take a picture of. Okay. All right. So I'm going to hand this back to Abdel. I apologize that we went a few minutes over. So hopefully some of this information was useful. And I hope to maybe one day come see you all in person once the world gets back to some kind of normal. So thank you very much. Shukran. And I'll hand it back to Abdel right now. Thank you.
Yes, thank you, Mr. Rizzi, very much for the helpful information we got from your session and about machine learning and APIs of Google. Let's see if there is any question on the chat. So far, no, but if anyone want to ask any question, I will unmute, I will open the mic also for everyone.
Yeah, it turns out I'm not getting your audio because I think I plugged in my microphone when the meet was going on. So if there's questions, I'm going to have to disconnect and reconnect so I can hear all of you, because right now I cannot hear all of you. So if somebody can capture all of the questions that are asked in the chat, that would be great. I will still come back. I will dial out now, but I will come back to answer any questions that I can. But if somebody can save them, because once I log out, I lose the entire chat. So if somebody can say that, that would be very useful. So let me dial out and dial back in, and hopefully I'll get audio from you back again. I'm going to stop presenting as well, too. So take a picture. I can present again later if I need to, but I'm going to stop presenting right now and then log out. All right, so I'll see you in a moment.
Okay. Zainab, when he come back, you can ask your question. Unmute yourself. Okay, hi, Ozzy again.
Hello, I'm back.
Okay.
So yeah, I may ask you to email me the questions as well in case we don't have time to cover everything, because I want all of you to go home safely and not have to worry about staying too late.
Just one other question. Zainab have raised her hand. Maybe she has some. Zainab, you can unmute yourself.
Hello, everyone. Hello, Mr. Wesley. Thanks for the amazing presentation. My
Sure.
question is regarding Google BigQuery. So I would like to ask, how can we know more about Google BigQuery? How can we learn more about it? And how we can get more information regarding the healthcare BigQueries?
Okay, that's a good question. Thank you, Zainab. So BigQuery, let's see. I'm taking notes because I want to know what people ask. So I think the best way to learn about BigQuery is from the one slide that I had all the links, especially especially the slide that had the information regarding the sandbox. So definitely you want to go using the sandbox, because the sandbox is free to use, and you can actually just try it. There's a web interface as well too. So let me see if I can present the one slide for you. Like I said, you can get access to all of the slides, but I just want to show you just this one. This is the slide that I was talking about. Oh, do you not see it? Yeah. This one. So definitely look at the sandbox. And if you just go to cloud.google.com/BigQuery by itself, that is the product homepage. So that'll give you sort of like the entry point. But if you want to learn more about the sandbox and how to use BigQuery for free, we have so many public data sets for free you can start using. It's really an amazing tool. I think we asked people a couple of years ago what is their favorite cloud platform tool, and a lot of people said BigQuery. So I'm glad that you asked, and we have a lot of code labs that help you get started with BigQuery as well too. So you can just do generic searches. I hope I can find one. So you can just do BigQuery, and then just look on codelabs.developers.google.com, and let's see how many. Oh boy, there's a lot of code labs. Okay, yeah, there's a lot of BigQuery code labs, so you can learn more about it. Probably I recommended go to gclab.me, which is basically all of our code labs in cloud. And so you can filter by category and probably pick just the BigQuery ones. Uh-oh, I don't see it. Maybe it's in data. Okay, well, you'll have to just dig around, but we have a lot of code labs in here. I'm surprised that there isn't a separate category just for BigQuery. I assume there would be, but yeah. So maybe just look through them all and try and find one that's interesting to you. But yeah, BigQuery is very well liked. So hopefully that answers your question.
Yeah, thank you a lot.
Okay. Anybody else? Abdel, I think you're muted.
Oh, yeah. Oh, sorry. I don't think there is more question. Also, we almost run out of time over much, so we will keep the sheet for the questions.
Okay.
And I will let you know if you need any help.
Okay, yeah.
Also, we will share a feedback form with the attendees. So if you want to have another workshop with Mr. Weasley, we can arrange that together. So thanks,
Yeah,
everyone.
I'm happy to walk you. Yep.
Yeah.
I'm happy to help walk through a code lab as well too. So okay, great. Does Roni have a question?
Yes, yeah, raised his hand. You can unmute yourself, Ronnie. The last question.
Good day, everyone.
Hello.
And hello, Dr.
Hello.
Mr. Shan.
Yes, thank you.
I have a question regarding, do we need, if we want to work in this AI and machine learning sector, do we need a degree, or we can just depend on the projects that we do? I need your expertise on this, please.
Okay, yeah, the main reason why I'm giving this talk is just to tell you, no, you don't need to have a lot of experience doing it. Of course, if you have a degree in computer science focused on machine learning, or if you have a degree in data science, of course, you can definitely get into this sector. But if you don't have that, then that's what this talk is all about. It's basically for a software developer like yourself or like myself. We don't know anything about machine learning, but we know how to call APIs. And as long as we know how to call APIs, we can leverage the power of machine learning. So, you may not be able to get a very sophisticated job right now. If you were to enter the field, and you learn how to use the APIs, you could probably get a job, but it may not be, the most high-paying job. It may not be the most sophisticated job. But the fact that you can use machine learning already just by calling an API is very powerful. And so you can slowly get into this field more. The more you learn about the APIs, and then you can learn to use AutoML, so you can learn more about training your own models. And then you can develop your mathematics skills and statistics skills. and then you can learn how to use TensorFlow and things like that. So it just gets more and more complicated, but your experience will grow and grow so that you can eventually become a full data scientist if you want, or a machine learning engineer. But yeah, you don't have to have a degree. It just depends on who is willing to hire people that have some machine learning skills and having this background. So yeah, you can definitely get into the field, but you won't get the top job yet. But you slowly make your way there, and this is the best way you can get, one of the easier ways that you can get started. Because if you try to get started just by going straight and becoming a data scientist and learning TensorFlow, it can be very, very challenging. So this makes it so that your on-ramp is more smooth and even and easier and not like so difficult. Okay, so hopefully that answers your question.
Yes, thank you, Doctor. Thank you.
Sure.
Okay.
Anybody else? Oh,
Oh.
wow. Everybody comes in. Okay.
If you
Celine?
have time, you can pick the question. Yes, Celine, you can.
Hello, I'm just going to ask a very quick question.
Sure.
Regarding the learning path towards machine learning, would you recommend going through the path that's mentioned in one of the slides, like starting out with calling the APIs, then learning a bit more about the model that's already created, then going into our own made models, basically?
Mm-hmm.
So you wouldn't recommend going at it in the first place, like just going into the science behind the math, the statistics, the things that are basically feeding the model that's being created.
Mm-hmm. Yeah, I think if you have the mathematics background, then I think you can go straight into it because, or statistics. You may have to review a little bit about what you did in university, but yeah, if you already have the background, then you can go straight into it. Otherwise, that one slide that I had where you kind of like slowly make your way there, perhaps, let me see if I can find it here. Here. You can like, if you already have the math background, you can just like forget all this stuff and go straight to the right hand side. But if you're completely new, start off with APIs. If you are, if you're comfortable with the APIs already and now you want to start learning about training, then that's when you go to AutoML. So, my example of training the Cloud Vision API for AutoML vision, where you're actually taking our API and further customizing it for, again, identifying, birds, flowers, fish, just identifying something more specific than just general vision APIs model. That would be a good thing to do. And then when you're done with learning AutoML and you're comfortable with that, then try some of the other tools in AI platform where you can start experimenting with Keras and TensorFlow and maybe PyTorch and start building and training your own models using the AI platform or Vertex AI. So yeah, so you basically make your way to the right and you go as fast as you're comfortable with. Okay.
Thank you so much.
Sure. All right. So I think we're an extra half hour over. So I'll let you guys go and I'll hand it back to Abdel.
Yeah. Thank you again very much. We hope to see you very soon. And as we said, maybe sometime in Lebanon. We thank you everyone for joining today also. And see you in next events.
All right. Thank you, everybody. And your last chance to take a picture of the slides as you sign out.
Yeah. I already do. I will share it with the link with the audience.
Okay, great. And then Abdel, if you could email me all the whatever chat questions that you think are interesting, that would be great.
Okay, sure.
All right. Thank you, everybody. Have a good evening.
Okay. Goodbye.
All right.
Good morning for you.
Yeah.
Yeah.
All right. Sabah khair.
Sabah khair.